Good day and welcome to my channel, the channel where we make structural engineering very simple and easy to follow and comprehend. My name is Olodukonyede and I'm your host. I want to say a very big thank you to everyone who has subscribed to our channel, those who have been sending encouraging words to us. We say thank you very much. And if you are yet to subscribe, please hit the subscribe button, like our page, like the channel, and you can share. So we got some interesting comment from our subscriber. We have Abdulaziz Abdullahi. You didn't tell us where you are commenting from. You said, my brother, please, I would like you to give me notes about reinforced concrete according to BS 8110 from slab to footing. Yeah, Abdullahi, we are creating an online video course that is simple to understand for everybody, even if you've not done anything on ProtaStructure. Hopefully this week will be done. We are almost 90% through with the training course. It will be a video that explains everything from importing from AutoCAD to exporting to AutoCAD to analyzing ProtaDT. Everything will be broken down to the barest minimum, to the simplest form. So just give us this week. Hopefully it will be out before this week runs out, and it will be available for you and everyone that is interested in that course, the online course, to key into it. Thank you, Abdullahi. So, and we have another subscriber, Engineer Doga. You say, good day, engineer. Thanks for your great videos on YouTube. Thank you, sir. In ProtaStructure, please, do you have any video? You said, I have checked on waffle slab design, rib slab design, polystyrene slab design. Thank you. Do have a great week. Adoga will be doing something of that today. We'll be putting out a video on how to design your waffle slab, your rib slab, and either your clay pot or polystyrene slab design. That is what we will be doing today. And if you pay attention, and those who are yet to subscribe, please hit that subscribe button. That is the only way you can show appreciation of these valuable videos we keep putting in day after day. The only way you can appreciate what you are gaining from us is to subscribe and send us encouraging words. And when you are sending us, please tell us where you are commenting from. Thank you very much. So we dive straight right in. We design for rib slab, for waffle slab, for hollow pot slab, for polystyrene slab. They all have similar principle, same principle of design. So majority of the time when we use that slab design is when the span of the slab is very big and they don't want a drop beam in plain sight. Then it is advisable to go for either the rib slab or your waffle slab or your hollow clay pot slab or your polystyrene slab. So those are slabs that can be used for long distance, very long distance, and it will be nice and aesthetic to look at. So we'll start immediately. When you want to start, let's use auto generation. We have 5, let's say we have 6, let's make this 6. Let's say okay. So if you look at your we're having 6 meter this way, yeah, 6 meter this way, 5 meter this way. Okay, so if you look at it, these are quite some large span slab that we have. We will just do this very quickly. All this we've already done in previous video. Please check out previous video. This is the column. Create your column. We say 230 by 230. If you don't understand anything, please go to our previous videos. It will explain it very well. Just go through. So insert your columns. Insert your columns. Insert your columns. Good. Then we'll go to our beam. We say 230 by 600. 600. Okay, we are good. Now we will do something here. We are going to do the different slab. We'll do for rib slab, we do for waffle slab, and we'll do for solid slab. So we will say this, let's make this top rib, let's make this middle solid slab, and this waffle slab. So let's create our slab. Let's make it 150. 150. We'll come here, our room. Let's say an office is an office for office use. Let's say office use. Good. Office use. Then for rib slab, we click on this rib icon. We click on this rib icon. If you look at this, BW is the breadth of the web. The web, or you say the rib. The web was the thickness of the web. Then H is the total height of your slab. Or if we are working on solid slab, we would have said this is 150, while this is 1,000. Is 1,000 for normal solid slab. But since this is not a normal solid slab, a rib slab is like a T-beam. It's like a T-beam. It's like a T-beam. So we will do, let's do 125. Then the height, let's make it 250. I will explain something here. So if you look at this diagram, we are focusing on this first. I will explain this later. This is our rib, the rib slab, and it will continue in this direction. Another rib connecting together. When they are asking for this BW, the BW is between here and here. Between, if you put this, becomes the BW, the rib between this. Then the topping, which is 50, we are using 50 here. The topping, which is H top, we say 50. Then for this S block, we are using 425. That is what we are using, 425. So this is when you are working with the rib slab. Then let me explain something about your clay pot, your hollow pot slab. Your hollow pot width is 400, and you give a space of 25 where you pour your concrete to hold it together. Then the space in between is 125, and you have your 50 mm topping, So the only difference between the rib slab and the waffle slab and this polystyrene or clay pot, depending on what you want to do. The rib slab, there's nothing inside here. So if you have your rib slab here, this part will be void. But if you are using polystyrene or clay pot, you use that as a filling there, instead of it to just be open without any thing filling it or exposed to the topping, the top slab, the topping, which is 50, this top slab. Instead of it to just be open, you either put polystyrene or you put your hollow clay pot. So between these two clay pots, at middle of it, the distance between it is 425, which is from here to here. Then this, our breadth, the web breadth becomes 125. So this is the same principle. How you handle it is the same principle. So we proceed. So once you do that, you see this becomes your load. Then this, what you do now, this becomes your load. Pay attention to it. Same principle. If you look at your top slab, your topping, if we do our topping, if you look very well at our topping, you see we've changed the 50 mm to a meter, 0.05 times the 425 mm that we have, times 240, which is a specific 24, which is a specific weight of concrete. You will have 0.51. For the rib, which we use 125, you change it to that, and our height, which is 0.2 times 24, it will give us 0.6. Our finishing, which will give us 1.2, which is 0.1, and if you add up everything, you'll be having 1.62. That is what we will be having, 1.62. 0.62. So if you come here now, you come here, if we say roof, it gives us this. We say we are using roof, here we have this. So it's the same principle that we are using self weight of this. So we click and we click. So pay attention. If you look carefully, you must place your rib or waffle slab in between beams, in between your beams. So if you look carefully, this thing is spanning along parallel to our 6 meters. So the rib is spanning 6 meters, but we can either change the direction of it so that it spans parallel to the 5 meter, which makes it much more economical and robust to handle the load. So in that way, if we click on this rib angle, we change it to 90, update, it will change to that. We say 90, update. Okay, we say update, rib, we say 90, update, we say 90, update. So we've done this, but in doing this other one, okay, we've done for the rib. Yeah, let's do for waffle. If you want to do for waffle, instead of this standard size, we change it to grillage, and we can increase this. Let's say 900. Let's make this, okay, let's make it 800. So we click. So this is what it does. If you look at it, you can save your work. This is the rib slab, this is the waffle slab. Then you can analyze your structure. You can run your analysis of the structure so that you have everything. You can run your analysis. You say analysis, load combination. Just go through our former video. If you don't understand, we can change. We say column, where this column becomes 16, and we take out this. We say beams, we take out this. Okay, we say slab. Let's make our slab 12. Rib, we can make our rib, let's say 2, take us, we can say 16, 20, and we stop. Link, we say our link is 10. For this, we say 12, 16, 20, and We say okay, we close, analysis. Okay, close. So once you've done this, you can go to settings, our slab settings. We say it's 200, make it 200. We say okay, save your work, go to building analysis. We do this and analyze. Okay, we are done. Let's come to this. You take your slab strip, cut through your slab. We'll come to this part, in to in, cut. Okay, then we come here to do this. Please pay attention to analyze this your rib and waffle slab. You must do them based on finite element method. Let's take this finite element. Let's take out this. Take out this. Finite element. Bob to bob. Bob to bob. I will say bob to internal. Sorry, if we're doing the Y direction, we must use Y. Let's use Y. Okay, if you've done that, come to finite element floor analysis. Your slab, let's change the stiffness to 0.25. Then we run our floor mesh analysis. Okay, we can change this to 100 and we run our analysis. Okay, let's close. Let's come to post analysis. Okay, post analysis. Okay, with the post analysis now, you can see your deflection. You can see how it's deflecting. You can see your deflection here. So this is your deflection. So if you look very carefully, the rib slab deflection is not really much compared to the others. Mostly the solid slab is the one deflecting heavily is the one deflecting heavily. So this is what we do. We close, you say okay, you close. You can either say update slab. Okay, so after you've done that, come to concrete design, then come to rib slab. Your rib slab, it will show you this. You can now say calculate bash and see this becomes your reinforcement. This becomes your reinforcement. So we are having 2y16 at the bottom, then 2y12 at the top. So this is your reinforcement. This is your reinforcement. So these are the rib slab that you design, and everything is okay. You close. So once you've finished the analysis, come to load Prota detail so that you see your work. You load Prota detail, just load it and come to here. We check on rib beam elevation. We say yes. Okay, insert, repeat, distance to edge, everything is okay. We say draw, we click. So it produces your work for you. So you see it, this distance now, this is the reinforcement it will be needing. This is your work. So we will stop here. If you have any question, please send in your comments, send in your comments and tell us where you're commenting from. And if you are yet to subscribe, please hit the subscribe button for you to get notified when we put up videos like this. Thank you and remain blessed.